So I bought this adapter charger, and it was supposed to be USB PD, and it says right here PD 33 watts, total of 65 watts. It's supposed to be GaN, gallium nitride, which is supposed to be this new technology that's, or relatively new technology that's really good. And right here in the description it says 65 watt adapter, charging type USB-C PD. Okay, so I assume there's going to be a way for it to do the PD power delivery negotiation. And I assume that there'd be a chip in there and that it at least could put 33 watts out there. So I bought this adapter, and the first thing I did was try to get some negotiation going so I could get the 12 volts or 15 volts out of this adapter. And let me show you what I've got. Connect my device, and then we're going to run it. So it's already plugged in, everything's ready. And there's some data being sent here. So let's look at this data. So we'll look at the data. We've done this before, but we'll do USB PD. We're going to select the D and D1. And I'll move it up here. And let's see what we got. And this is what I got. I have what this says, sync. So that's messages from the sync device, which is my little decoy board that's going to request voltages. This is also from the sync, and this is also from the sync. And if we run it longer, so let's actually do like 10 million samples, just to make sure we're not missing something. And then we're going to hit run, and then, oh, I missed it. Hang on a second. Okay, so I plugged it in. You can see the source, sorry, the sync. Sync is asking for data again, like we saw before. Nothing. Okay, so it's very frustrating because it doesn't look like there's any USB PD working on this device. Even if you go to here, it says it's supposed to be 33 watts. It should advertise something. Now, this is what only data we're getting for USB PD right now. Okay. Now, one thing to note, if we want to open an existing. So this is a working adapter that I have a different adapter I plugged in, and I read the data and I saved it to my desktop, and then I pulled it up just like this. And so you can see the first thing that happens, if you zoom out and then you zoom back in, first thing that happens is the source gives you the capacity, fixed 3 amps, 9 volts, 12 volts, and this was on the last video. And so just like in the last video, this works fine, but the problem I have is that when I did it earlier, just a second ago, with my new device, this one here, it didn't do anything. So there's something wrong. So we're going to take this thing apart, and we're going to dig into, is this like a complete counterfeit clone? Does it even have any of the capabilities it should have? Because on the sides of it, it says, and it's kind of, you can't really see from here, but it says it's supposed to be able to put out like 7 amps at 9 volts, and then it's supposed to put out 12 volts at 5.4 amps, and then 20 volts at 3.5 amps. So that's some serious voltage and current, and that's a lot of power. And I don't see anything happening here. So let's just take this thing apart and see what we can see. So let's get this thing open. It says right there, PD 30 watts. So I mean, that means like this thing doesn't work at all. So what I'm gonna try to do is just get this thing open. That's it. Wow. That's all I can say is wow. Let's digest this for a minute. We're gonna pull this glue off. Yeah, this board's so cheap. Alright. So it looks like we got an MT3612. So I'll write that part number down. And then it looks like we have this right here, and it's kind of hard to read. An MR10F, and then there's this one here. What's that chip? Can I read it? Yeah, if we get the light just right. We looked at the chips. So these are the main chips. Is you got the AC to DC rectifier bridge. Doesn't have to be very big because the currents are low, because you got 120 volts coming in. And then you've got this chip here, which is your flyback chip, and I'm going to show you that. And then this is your communication chip right here. This little tiny deal. And this, I think, is looks like your rectifier. So let me show you that. So right here is the schematic for that chip.
the chip that's right here. And interesting thing is, this is all supposed to be very inexpensive so that they can sell lots of these and make money on them, obviously. But you basically have your input power, 120 volts in here. And then you have a fuse. Now, they didn't really put a fuse, but they did put this resistor here. So I'm assuming that that's kind of a custom-made fuse or serves the purpose of it. And then you have the chip. And the chip basically controls this transformer, which also has feedback from here. It has feedback. So you have this transformer, and then you have a third winding here, number 5, that feeds power to VCC. So I think this R1 and R2, which this is what it looks like, and there's no really data sheet for this. I couldn't really find a lot of information, just a schematic, since it's like a Chinese chip, which is often the case. If you can't find a chip, there's not a lot of information. You kind of just have to guess. But R1 and R2, I believe, feeds power into VCC so the chip can wake up. But once it starts like switching on and off, then it looks like V1 would provide rectified power with C3 as a filter. So this is kind of just a generic thing, and then also you got feedback here. So based on this resistor divider and the voltages here, you will get feedback on this chip, which will, based on the transformer, what's happening in this transformer, which is the same as this one. They're just showing differently here. It's one big transformer. So then this winding basically will know what's happening in here and feedback. So that's how this chip knows how much duty cycle to be switching this transformer. So that, and then you got an output rectifier here and some output caps. And this is almost basically identical to what they have here. They've got the transformer. There's 2 windings, so this is one winding, and then there's an inner winding, and then you got the chip. And then basically, based on this, we know right away, it says 9 volts, 7 amps, 12 volts, 5.4. It doesn't even have 5 volts on here. Well, this is all a complete lie, because number one, these all have to be at the same voltage because they're all tied together in here. And if they're all at the same voltage, then that means this one, this one, this one. And the reason why we know they're all tied together is one transformer and there's nothing else going on in here. So based on that, you know, this one, this USB-A and these USB-Cs are all in the same voltage, which that means they have to be in 5, because if these were to negotiate a different voltage and you plug this in, you would fry whatever else is getting plugged into this, because you know, if that device only supports legacy charging at 5 volts and you plug it in, and these had negotiated like something else, then your voltage is wrong and you can fry it. So that default has to start at 5. So these can never go any above 5. And now, so when I looked at that, I was kind of surprised, because they say they got 20, 12, all this and that. Well, they also have this other chip on here, this negotiation chip, and we're going to get more into this later on, but it's called like a quick charging chip, and all it does is negotiate with the phone or adapter, telling it, hey, by the way, this port can support more current. It can't support any more voltage. Now, quick charging can tell it we can also negotiate a higher voltage, but no, on this one you can't do that because, like I said, they're all in the same bus. So finally, this chip, the MT5889, it has 2 D plus D minuses that negotiate on that, USB 1 and USB 2, and then it just knows this is my V-bus and my 5 volt power and powers this chip. So there's really not a lot going on with this thing, but it's way cheaper than I expected, honestly, because I thought, you know, it's a single layer board. There's only copper traces on the top here, and then, or on the bottom, I guess, and then top of this board, if you'd want to look at it that way. But there's no traces on this side. It's got like 2 caps. I mean, this thing's very cheaply made, and to be honest with you, it's quite a bit of a lie, because they say 9 volts, 7.2 amps. Now, I wouldn't have known that unless I had used my little adapter and plugged it in and looked at the CC lines and found out there was no communication going. If there's no communication and I couldn't get the 20 volts out, I quickly realized this was a fake. It's a counterfeit. It's junk. But, I mean, it still will charge a phone just way slower. And so if you have issues with your phones, you know, you got to find out what's going on. And then also, lastly, they got this like clay, and it's basically a thermal mass. So they kind of pushed it on there, and then they put it in there. I suppose it gives it some weight too, so it doesn't feel super, super cheap. Otherwise, this thing's so light. And also kind of keeps it cool and lets the heat get out of the case through the clay. So that's it. Like, it's, you got this that plugs in like that. This whole thing is just very, very inexpensive. And Um, yeah, it's all a lie. It's not USB-C, PD, or anything like that, even though it says it. And definitely don't think you're getting 65 watts out of there.